Once all the dry fitting is completed, the system is now ready to be bonded together. Dry fit joints can be left together until it is time to bond them to help protect them from damage and contamination. The first bonding to be done is at the sump penetration fitting. Remove the nut and flange ring from the fitting body and the body from the sump wall. Sand the sump wall, inside and outside, where the fitting will be bonded, and the mating fitting surfaces with the emery cloth contained in the adhesive kit. These fitting surfaces include the flange face on the fitting body and the flange face on the loose flange ring that will go against the sump wall. Adhesive mixing will be described in general at this point. PSX 20 adhesive kits are typically used for all bonding. An alternative adhesive, PSX 34, is also available and can be supplied on request. These adhesives are exactly the same, with the only exception being the viscosity. PSX 20 is less viscous or thinner than the PSX 34. It is more workable in cold temperatures. Adhesive kits are available in 3 sizes and 2 quantities. 3-ounce, 5-ounce, and 8-ounce kits can be provided to order. Single kits or 6-packs of any of these sizes are included. The kit size most appropriate to be used depends on the situation and conditions. Once mixed, the chemicals in the adhesive begin to react and do so at a rate relative to the temperature. Under warm conditions, it is advisable not to have too much adhesive mixed at one time. The installer does not want it to react before they are ready to use it. Likewise, when bonding larger sizes and containment fittings, the installer does not want to have to mix several small kits to make a single bond. Experience of the installer also plays a role in how quickly adhesive is used and what kit size best fits the conditions. Adhesive kits come with all components needed for use: instructions, gloves, a mixing stick, spatula, brush, paper towels, a strip of emery cloth, and the resin and hardener cans are included in the kit. For the 6-pack, the appropriate number of each component is provided. The spatula provided is designed to have a square corner on one side and a rounded corner on the other. This is intentional to allow more material to be removed from the corners of the cans using the square corner and a smooth bead to be formed at the exterior bond using the round side. Before mixing any adhesive, be sure all bonding surfaces are freshly sanded and all glossy surface has been removed. This will assure the surfaces are not contaminated and a good wet out of the surface will be made by the adhesive. If a bond surface has been contaminated, resand the surface until all evidence of the contamination is removed. Flapper sanders can be used if care is taken not to oversand and change dimensions or angles of the surfaces. When the kit size is chosen, all of the hardener must be mixed with all the resin. Never attempt to split a kit, and only use half or some other portion of it. The quantity of the ingredients is precisely measured and yields the proper ratio when reasonable effort is used to mix up as much of the kit as possible. Using only portions of the resin and hardener contents virtually guarantees an incorrect ratio, resulting in a weaker and less chemically resistant adhesive. If multiple size kits are being used at the site, be sure both the resin and hardener cans to be mixed are labeled with the same kit size. Proper personal protective equipment, including the included gloves, must be used. After removing and discarding the lids properly, the hardener should be mixed into the resin. The resin can is sized to allow the volume of both can contents and room to mix them together. Remove the hardener with a spatula or mixing stick and mix completely with the resin. The resin and hardener are of different colors to help show when the two have been properly mixed. Even after all streaks of different colors are gone from the mixture, continue to mix until the entire contents are one uniform and fully mixed color. The adhesive formulation includes some grit. This grit should never be dumped out of the resin. It is there for the specific purpose of helping to lock the tapered joint together, giving a good feel that the joint is properly assembled and preventing it from backing out before the adhesive cures. Some cold weather tips. Adhesive resin and hardener can be kept in a warm place such as a shop area or cab of a truck to make mixing easier. Another method used is to wrap a heat blanket around the 4-inch diameter pipe leg and stack the adhesive cans inside the pipe, letting it act as a warming chimney. As a can is removed from the bottom of the stack, another can be placed on top to be warmed as others are used. Pipe spigots and fitting bells can be pre-warmed also by inserting the coiled heat blanket into the pipe interior with the thermostat to the inside, or wrapping it on the outside of the fitting. This practice does not relieve the need to heat cure the bond if ambient temperatures are below 50 degrees Fahrenheit. Returning to the sump penetration fitting bond, apply a uniform amount of adhesive to the sump wall openings and the fitting flange faces. You should never apply excessive amounts of adhesive to one bonding surface and none to the other surface in an effort to average the amount being used. Both surfaces on every bond, whether for sump penetration fittings, tapered primary joints, or clamshell containment joints, should have both bonding surfaces wetted with adhesive prior to matching them together. Insert the fitting body through the sump wall from the inside. The test and drain ports should be in the 12 o'clock and 6 o'clock positions. Place the loose flange ring over the fitting body from the outside of the sump and against the sump wall. Screw the nut onto the fitting body by hand until the fitting firmly grips the sump wall and does not move when released. A bead of adhesive should squeeze out all the way around each flange, both inside and outside. This will assure a full seal on both surfaces. This is particularly important on double-wall sumps. It is recommended to use the curved corner of the spatula in the adhesive kit or a gloved finger to trace the bead around the flanges to remove excess adhesive and to remove any air bubbles that might have formed in the bead. The sump penetration fitting bond should be allowed to cure before further bonding takes place. The primary system is bonded prior to the containment system. The bonds are taper bonds between pipe and fittings. Apply enough adhesive to the bell, female, of the joint to wet the surface. Excessive amounts of adhesive are wasteful and actually cause problems with the cure and later flow. You cannot apply too little adhesive to the bell if the surface is wetted. If the adhesive does not readily flow into the surface, such as in cold weather, additional warming should be done to the surface to get good wetting. Adhesive can be applied by using either the brush provided or the spatula. It is a matter of personal preference, and each tool is chosen by many installers. Both are supplied so that the choice can be made by the installer. A more liberal amount, although still not excessive, should be applied to the spigot. The entire ground surface of the spigot must be wetted to assure a good bond. The cut end of the pipe should also be wetted with adhesive. When the surfaces are covered, the joint is ready to be assembled. Insert the spigot into the bell with a slight rotating motion about the axis of the pipe. When inserted, a properly prepared joint should not allow more than about a quarter turn before locking. If more than this happens before locking, less total adhesive should be applied to the next bond. If an excessive amount of adhesive pushes out of the joint, more than a couple of drops, and then it rotates freely for more than 1/2 turn, pull the joint apart, clean it, and start over with less adhesive. You will develop a feel for the right amount of adhesive as you progress. After the joint feels locked after rotating in one direction, apply a reverse twist to finish the lock. No more than 1/8 turn should be possible, if any occurs. If twisting the bell or spigot is not possible, the joint can be made by straight insertion of the spigot. Less of a feel of the locking happens, but the joint is fine. If there is any question of the fit of the joint, it can be checked by placing a block of wood, such as a 2x4, outside the bell and giving it a light tap on the wood with a rubber mallet. This can be repeated if movement is seen on the initial tap. When the pieces fit together, a small amount of adhesive should squeeze out of the joint around the full circumference. If no bead is formed by this, additional adhesive should be used so a visual feedback can be seen when the joint is fully sealed. The rounded corner of the spatula or a gloved finger can be used to form the surface of the bead around the joint and remove excess adhesive from the exterior. This action also removes any surface bubbles that may have formed in the exterior bead. If the taper-to-taper bond is properly made and locked, the next joint in line can be assembled immediately. It is advisable to spot check prior bonds to assure no movement or backout has occurred. If the ambient temperature is below 50 degrees Fahrenheit, the adhesive must be heat cured to develop adequate strength and chemical resistance. Heat blankets and ChemCure packs can be used for this purpose. The heat blanket has a self-limiting thermostat built into the blanket to assure it does not overheat. The end of the blanket with this thermostat should be placed into the bell exterior, centered on the middle of the bond area, and the remainder of the blanket wrapped around until it is fully in position. The side of the blanket with the Velcro strap should be to the outside. The same blanket is used for 2-inch through 4-inch pipe. Note the time on the pipe when the heat cure was begun. This can be used later for reference to know when the full cure time shown in the adhesive instructions has been completed. If it is extremely cold, or if wind is blowing away much of the effect of the blanket's warmth, a layer of fiberglass insulation can be wrapped over the blanket to assure the heat is going into the bond rather than being driven away by the conditions. ChemCure packs can also be used to cure the joints and are very handy when electricity is not readily accessible. These packs come in cases and are clipped and stacked in the case. The wrapper around the pack is folded to prevent mixing of the chemicals within the pack. The pack is formulated to exotherm, or give off heat, when the chemicals are mixed and water is added. Since water can be prevalent on a job site, prevention of chemical mixing is a prudent feature of the package. As with the adhesive, components of the ChemCure pack are of different colors. Again, this helps identify when the components are properly mixed. Once mixed, the pack should be laid flat and the mixed material spread evenly along the length of the pack. The pack should then be centered under the joint, wrapped up both sides, and the top of the pack rolled to assure good contact all around the full circumference of the wall. Wire ties are provided to hold the pack in place while the bond is being cured. A syringe is also included, used to inject water into the pack. Once in place, 1 or 2 small slits should be cut in the paper portion of the pack near the top of each side. The syringes should be filled with water and half used on each side of the pack. When the water is injected, the properly mixed pack will begin to react and generate heat very quickly. Steam should escape through the slits in the paper. No further actions are necessary around the pack. The pack gets very hot and should not be touched until the reaction has completed and the remaining material, much like salt, has cooled down. The pack can be removed and discarded. Now that the bonding is complete, let's go on to Chapter 5 on pressure testing and final assembly of the containment.